So today we're talking about common bases. What does the word base mean when we think about exponential functions? When we say the word base, what are we talking about? Say again. The bottom of it, right? Yeah, the thing that we keep multiplying. Hood off, please, and thank you. Hood off. You'll be all right. Okay. So when we have an exponential equation, remember exponential equations are just equations that have a variable in the exponent spot. When we have an exponential equation, the only way that we can solve these, we're on page 13, the only way that we can solve these, did your packet fall apart?
It did.
I'll bring you a stapler.
Thank you.
You're welcome. The only way that we can solve these is if we have a common base. A common base. So let's look at our first example. 1a, it says solve each of the following simple exponential equations by writing each side of the equation with a common base. So I want you guys to look at your power chart. I have 2 to the x power equals 16. We have to figure out what x is. So find 2 in your power chart and kind of drive it over to the right until you find, or actually yours goes this way. Drive it down until you find 16. What power of 2 is that? 4. So that was really easy. So that just means x equals 4. Okay, I'm going to give you 30 seconds to do the next one. 3 to some power equals 27. Figure out what that some power is. What'd you get, Hayden?
X equals 3.
Yeah, x equals 3. And I'm just going to write, I know that because 3 to the third power equals 27. That makes sense. I have a fraction, and I don't remember what happens to my exponent to turn my solution into a fraction. What happens? It becomes negative. My exponent is negative. So when I think of these, this is how I think of problems like this. I think, 5 to what power equals 25? And then I write myself a note that says negative. That's how I think about that. I don't get caught up on the fraction. So 5 to what power is 25?
-2.
Good job. So this is going to be x equals -2. How are we going to think about the next one? Negative what? That's going to be 1 over 16. 16 to the -1 power is 1 over 16. But you're thinking along the right track. So I'm going to do some magic over here in the corner. Is it what? 1/4? You're really close. So I'm just going to talk about exponents for a second. 16 to the first power is 16. 16 to the 0 power is, I was waiting for someone to say 0. Good job, you guys. 16 to the -1 power is 1 over 16. Let's see. This answer that we have, 4, is going to be somewhere in between these two numbers, right? 16 to some power equals 4. It's going to land in between that 1 and 0 power. So what if I were to write it like this? What is the square root of 16? It's 4. So you learned this in math 2. You learned that a rational exponent, when you have a rational exponent, that means a fraction. You learned that the top number represents the power, and the bottom number represents, we call it the index or the root. So this is just saying 16 to the 1/2 is the same thing as saying the square root of 16 to the first power. Do you guys remember doing that? Maybe. So this is really 16 to the 1/2 equals 4, because remember, this is the power and this is the root. So this is the same thing as saying the square root of 16 to the first power. Well, that's just the square root of 16. It equals 4. Okay? So x is 1/2. Good thinking, you guys. All right, so in each of these cases, even the last one, more challenging, we could manipulate the right-hand side of the equation so that it has a common base. So we want to think of how can we manipulate each side of these with a common base. So the first thing that I want to do is we need to talk about some exponent rules that you learned in 8th grade, definitely in Math 1. They were revisited in Math 2, but like you really lived them in 8th grade and in Math 1. So when I have a power raised to a power, what do I do with those exponents? You gonna make it?
Multiply.
Yeah, we multiply them. This is a multiply. Why? Because this is the same thing as saying, well, it just is. I'm not gonna even try to explain that because that's a variable term. But anyway, we just multiply those. Okay, so example B, 3 squared to the power of 4x. Again, I do what with them, Reese?
Multiply.
So we're distributing. So this becomes 3 to the 2 times 4x. And what is 2 times 4x?
8x.
8x. So this is the same thing as 3 to the 8x power. But what about the next one? What do you think, Miss Hannah? 5 to the negative 1 raised to the power of 3x minus 7.
Negative 3x.
What are you going to do with that? What are you going to do with that negative? What have we been doing? We take the power on the inside and do what with it? Multiply it. So you're going to do that same thing. So when you take that power on the inside, what is a negative 1 times 3x? And what is a negative 1 times a negative 7? Positive 7. You started off right and then you second guessed yourself. Okay? Do you not have your notes? You do? Okay. What about example D? What about example D? What are we thinking? Go, Zach.
-3 plus 3x squared.
Good job. 4 to the negative 3 plus 3x squared. Excellent. Okay, questions? All right, so the whole idea behind this is now you know how to, first of all, find a common base. Secondly, we know how to distribute powers. So now we're going to look at equations. So we're going to look at equations. So I have to say to myself, those bases aren't the same. What is a way that I can write 8 as a power of a number on your power chart that may also contain a 32? So I'm going to write both 8 and 32 as powers of some number. What do you think, Rose? Look at your power chart. What number raised to a power has both an 8 in it and a 32 in it? So let's look at your power chart.
Oh, 2.
2. So 8 is the same thing as 2 to what power? 2 to the 3rd power, but it's got a power of x outside of it. Okay. And 32 is the same thing as what? 2 to the what power? Okay, so do you see how we have common bases? Meaning that these are both the same? Let's rewrite 2 to the 3rd power raised to the power of x. How can I simplify that? 3 times x is, so this is 2 to the 3x power equals 2 to the 5th. What do you notice is exactly the same on both sides of the equal sign? The 2, the base is the same. So guess what kind of voodoo magic we get to do here? If the base is the same, you just get rid of it. Just drop the base. It's got to be the same. It's got to be exactly the same. So now what do I have left over? Well, I have the equation 3x equals 5. How am I going to solve for x, Michael? What would you do?
Would you divide by 3x?
Yeah, just by 3, not the x, okay? So x equals 5/3. Now, I know that you guys are a room full of skeptics, right? So we're going to check this because I don't believe it. I know you don't believe it. So I'm going to use my handy dandy calculator, and I'm going to type 8 caret parenthesis 5 divided by 3. 8 caret, pick up your calculator. 8 caret, remember that caret function raises it to a power. Your power is a fraction, so you need to use parentheses. 8 caret parenthesis 5 divided by 3. Close your parenthesis and hit enter. 32. Oh my gosh. Well, let's investigate that just a little bit. 8 to the 5/3. I just want to see if I can make this make sense in my brain. Because I'm not always going to have a calculator. Remember, this is the power, and this is the root. So this is the same thing as saying the cube root of 8 to the 5th power. Okay? But what is the cube root of 8? What number multiplied by itself 3 times is 8? 2. So this is also the same thing as saying the cube root of 2 to the, well, we're just going to get rid of that 8. Hang on a second. I'm going to just change that. That's not an eraser. I'm going to get rid of our 8. And the cube root of 8 is the same thing as 2 to the 5th power. The root goes away. So what is 2 to the 5th power? 32. Okay. So yes, I know that we have to use technology on our test, but it sometimes makes more sense if you can kind of put it in your brain and make your brain understand it. I'm going to give you guys a second. So let's talk about example B. I have 9 to the 2x plus 1 power equals 27.
How did you cross out
The cube root of
Yeah.
8 is,
how did you cross that out?
what is the cube root of 8?
It's a.
What number can I multiply by itself? It's 2. That's how I got rid of it. Okay? So, what can I do to 9? What base can I write that as? Huh? 3? 3 what? 9 is the same thing as 3 squared. Okay? So, really, I'm going to change 9 and rewrite it as 3 squared to the 2x plus 1 power. How can I rewrite 27, Nathan? How can I rewrite 27 with a base of 3? Look at your power chart. Look at Michael's power chart. Look at someone's power chart. So look at your 3.
B 3.
Hang on. So this is how it. These are the exponents. These are the bases. So 3 to what power is 27? 3 to the 3rd power. So we're going to rewrite that as 3 to the 3rd power. 3 to the 3rd power. So now, what do we have to do on the left side? Because I have a power being raised to a power. A power being raised to a power. Multiply or distribute that, right? So I always draw arrows so I don't forget. So this is really 3 to the 4x plus 2. Does everybody see that? 2 times 2x and 2 times 1 equals 3 cubed. Now what do we have? On both sides that are exactly the same.
Regular numbers.
Yeah, they're called bases. They're regular numbers. So we can do this voodoo magic where we just do what? Drop them. You have 4x plus 2 equals 3. What do you want to do to both sides? Subtract 2. 4x equals 1. Last step. Divide both sides by, good job, and x equals, okay. So if I were to check that, just because I want it to make sense in my brain, 9 to the, let's see, 2 times 1/4 plus 1. Well, 2 times 1/4 is what? It's 1/2, and 1/2 plus 1 is, or 3/2. Let's see, that means I'm taking the square root of 9, and whatever I get, I have to cube it. Well, what is the square root of 9? 3, and what is 3 cubed? Oh my gosh, isn't that what we just got? I just want it to make sense in your brain. I'm going to leave that one there, and we're going to talk about letter C. Letter C has a fraction. Letter C has a fraction. So what kind of common base do you see with the 125 and the 25? What is my common base? 5. Okay. So the first part is 5 to what power? 5 cubed to the power of x. Don't forget that little guy out there. What about 1 over 25? 5 to the what? Good job. So 5 to the -2 to the power of 4 minus x. So now we're going to have to distribute on both sides. So on the left side, I end up with 5 to what power? 5 to the 3x. And on the right side, I end up with 5 to what power? Say it again, -8. Good job. All right, David, what do I get to do now? What kind of crazy thing happens now? Drop the base. Sounds like we could make a song about that, maybe. I don't know. 3x equals -8 plus 2x. 3x equals -8 plus 2x. So now what? Divide both sides by. Are we ready to divide? Yeah, good job. Let's subtract the 2x first. Right? Get all your variable terms on one side. So this just says that 1x equals -8. 1x equals -8. So calculator bunny, I want someone to take 125 to the power of -8. And I want someone to take the fraction 1 over 25 to the power of 4 plus 8. Because minus a negative makes it a positive. So 2 people, grab a calculator and go. And turn them into decimals. Turn your answers into fractions. Hit your math, and then fraction button. Math, fraction, enter. Oh, it's still not doing it for you?
No.
Okay. Well, in my brain, let's see. 4 plus 8 is 12, right? So, do they equal the same thing though in your calculator? 1.67 blah 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 to the e to the whatever?
Yes. Yeah, when I do the fractions too, it's the same.
Yeah. All right. Is that it for that example? Do we have any more of those types? You still need to write it down? Okay. I made copies, but they're still sitting over there. The printer was jammed, and I had to beat it down for a little bit. Here, I'm going to give you mine to look at.
Is that 125?
125. I was just trying to have you put it in a calculator, but x is -8.
Okay.
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 You good with that, sir?
Yeah, no, no.
Okay. Which of the following represents the solution set to the equation 2 to the power of x squared minus 3 equals 64? 2 to the power of x squared minus 3. Are you making it? Yeah? Okay. Do you want to go get a drink of water? So we have to turn 2 into a base, or 64 into a base of 2. So what power of 2 is 64, Hannah? Look at your power chart. 2 to what power equals 64? Yeah. So I have x squared minus 3 equals 2 to the 6. Remember, when the bases are the same, I get to do what? Drop them. So I have x squared minus 3 equals 6. What are you going to do to both sides? Add 3 to both sides first. So x squared equals 9. When you physically draw the radical yourself, what do you have to remember? That every perfect square underneath the radical has, yeah, a positive and a negative. It has both a positive and a negative root. So what answer choice is that? It's answer choice number 1.